Welcome back. So, we're going to continue talking about special right triangles and types of right triangles. Your homework from last class is up, so pause the video so you can go over it. Otherwise, I am going to continue going through this lesson. So today we're going to be talking about sine, cosine, and tangent trig ratios. Okay? These are all trigonometric ratios. Now, what does that mean? Basically, a trigonometric or trig ratio is a ratio of the lengths of two sides in a right triangle. And we're going to break down the sides of a right triangle later in terms of how we're getting these trig ratios. So there are three different trig ratios that we're going to be focusing on. There's actually six, but we're going to focus on three. We're going to focus on sine, cosine, and tangent. And the abbreviations are listed right next to them. So if you have a calculator, you might see sine written as SIN. You might see cosine shortened as COS, and tangent shortened as TAN. Now, an acronym I want you to remember that we're going to explain later is SOHCAHTOA. Okay? SOHCAHTOA. What does that mean? Let me explain the next few slides first before we start understanding what OH, AH, and OA might mean. Yes, all the O's mean the same thing, all the A's mean the same thing, and the H's mean the same thing as well. I think you already guessed S, C, and T stand for sine, cosine, and tangent. So if I'm looking at a right triangle and thinking about trig, well, we know that trig is based on the ratios of the sides of right triangles. And as I explained earlier, there are 6 trig functions for any right triangle that are based on an angle that we're focusing on. Now, the angle that we're focusing on is usually not the right angle. It's one of the two other angles of the right triangle. And we refer to the angle that we're focusing on as the angle theta. Okay? This symbol right here that kind of looks like a 0 with a line going horizontally across, this is Greek, sure, and it stands for theta, okay? So these 6 trig functions are defined by ratios of two sides of a triangle. The sides of the right triangle that we're going to be focusing on in terms of the angle theta are the hypotenuse, an adjacent side, which is one of the sides that helps create the angle theta besides the hypotenuse, and the opposite side, which is the side directly across. So if I'm looking at this triangle on the right, okay, let's say that we call this bottom left-hand angle theta, okay? The hypotenuse never changes, it stays the hypotenuse. Directly across is the opposite side, which is right here. And then the angle is created by the hypotenuse and the adjacent side, which would be this side, okay? Now, if I change it so that this top angle is theta, instead, I know it's not labeled right now, but if I change it so that this top angle is theta, it's gonna look like this, okay? Let's pretend that it's shaped like the other one. Okay, if this top angle is theta, now this side becomes adjacent. This side down here at the bottom becomes the opposite side, and the hypotenuse stays the hypotenuse. Okay? The hypotenuse is always going to be the longest side, and it's always going to be opposite the right angle. We know this, we've said this a million times. And the opposite and adjacent sides refer to another angle other than 90 degrees. So when we're dealing with an opposite or adjacent, we're not talking about the opposite and adjacent sides of a 90-degree angle. We're talking about it in terms of theta. So one of these two other angles, okay? One of these two other angles besides the 90. So let's talk about our 3 ratios. First, we're going to talk about sine and cosine. Now, before I explain this, let's pretend that our theta or our angle that we're focusing on is going to be angle A, which is right here. Okay, this angle right here. Whenever you're finding the sine of an angle, you're always going to create your ratio by taking the opposite over the hypotenuse. Okay, so whatever the length of BC is over the length of AB, which is the hypotenuse. Remember that acronym I told you about in the beginning slides? SOHCAHTOA? What do you think SO means? Sine is equal to opposite over hypotenuse. So that's how we find the sine of angle A. What about the cosine of angle A? Well, what was that acronym? SOHCAHTOA? Ka, C-A-H. Well, the A stands for adjacent, and the H, which we just figured out earlier, represents the hypotenuse. So if I want to find the cosine of angle A, I'm going to take the length of the adjacent leg, which is AC, and I'm going to put it over the length of the hypotenuse, which is AB. Okay? So my ratio is AC over AB for the cosine, and for my sine, it's BC over AB. Opposite over hypotenuse, adjacent over hypotenuse. And then we have tangent, SOHCAHTOA. What do you think TOA represents? That's right. Tangent is equal to opposite over adjacent. So if we're still dealing with angle A as my theta, we're going to take the tangent of it, and that's going to be equal to whatever the opposite leg is, which is BC, over the adjacent leg, which is AC. So BC over AC, opposite over adjacent. It's tangent. So let's solve a problem based off of this. Example 1 says finding sine and cosine ratios. Cool. Let's find the sine of angle S, the sine of angle R, the cosine of angle S, and the cosine of angle R. Write each answer as a fraction and a decimal rounded to 4 places. Now I'm going to explain in just a second why we do that. Bear with me. So, first thing I'm going to do is I'm going to identify everything based on what angle we're looking at. So the first thing says find sine of S. In fact, after I do sine of S, instead of doing sine of R, I'm going to do cosine of S, because these are both dealing with the same angle, right? Angle S. S is going to be my theta for both of these. So let's look at angle S, and let's identify each part of this triangle. Well, if the right angle is here, that means that RS is my hypotenuse. So that's the easiest thing and one of the more important things that we can identify right from the get-go. If angle S is my theta, that means that ST, which is right here, and is 16, that is my adjacent leg. And then from S, I can draw an imaginary line that tells me that RT is my opposite side. Okay? So hypotenuse, opposite, adjacent. Awesome. So the sine of S, SOHCAHTOA, so being opposite, OH, over hypotenuse. So the sine of S is 63 over 65. I'm going to pause. If I have a calculator, I can divide 63 by 65 and get the decimal and round it to 4 places like the instructions say. Now, let's do the next one. I said I'm going to skip doing R since we're already on S, let's do cosine of S. Cosine, so ca, C-A-H. So I know C is cosine, so cosine of S equals A, which is right here, it's the adjacent, over the H, which is the hypotenuse. Okay, so the cosine of S is 16 over 65. So we did the sine of S and the cosine of S. So let's do R now. Now if I do R, if I change the theta from S to R, the hypotenuse stays the same, but now instead of ST being my adjacent, RT becomes my adjacent because we're dealing with R instead of S, and the adjacent side is 63, and the opposite side now becomes ST, which is 16. So, sine of R, sine being so opposite over hypotenuse. So the sine of R is 16 over 65. And then the cosine of R, so ca, is the adjacent, which is 63, over the hypotenuse, which is 65. And it looks like this. If you divide each one, you get these decimals. What I want you to really look at, and which you probably already noticed before I even said anything, the sine of S and the cosine of R are the same. The sine of R and the cosine of S are also very much the same. So why do they give you these, why did they make us change these fractions into these decimals? Why did I have to change 63 over 65 into 0.962? Why did I have to change 16 over 65 into 0.2462? So we need that in order to find the angles. Now, we're not doing that in this lesson, so don't worry about it, okay? But we use these values to figure out what these actual angles are, okay? I don't know what R is, I don't know what S is, I just know that my ratios for the sine of S and the cosine of R are 63 over 65. I just know that my ratio of the cosine of S and the sine of R are 16 over 65. I don't know what to do with this yet. We're going to figure that out in a later lesson. Don't worry about that right now. Instead, let's talk about tangents. In this one, we need to find the tangent of S and the tangent of R. You want to write each answer as a fraction and a decimal rounded to 4 places. So, let's look at angle S. Here's S, which means let's identify hypotenuse. It's the longest side. That's easy. 82 is bigger than 80 and 18. It's also across from the 90-degree angle. And if we're dealing with S, my adjacent side is ST, which is 18, and the opposite side is 80, which is RT. Okay? So the tangent of S, SOHCAHTOA, so tangent is equal to TOA, which is opposite over adjacent. So 80 over 18, which you can always reduce to 40 over 9 and then change to a decimal. Now, let's change our theta to R, because we found tangent of S, we need to find tangent of R. Tangent of R, we know SR is still the hypotenuse, that never changes. But now the adjacent side to R is RT, which is 80, and its opposite is ST, which is 18. So, TOA, tangent of R, is equal to the opposite, which is 18 over 80. Like I said, you could reduce 80 over 18 or 18 over 80 so that you get 40 over 9 and 9 over 40. And then when you change them to decimals with a calculator, you get 4.4 repeating versus 0.2250. Okay? Again, we are not finding the actual value of the angle, so we are not doing anything with these numbers. You will learn how to do that eventually. Find the value of x. Round your answer to the nearest tenth. So this one's a little bit different. This time you're given an angle and you're trying to figure out what one of the legs is. Notice I can't use the Pythagorean theorem because I don't know what the hypotenuse is. And since I don't know what the hypotenuse is and I only have a value of a leg and I'm trying to find the other leg, guess what trig function I have to use? Sometimes you have an option depending on whether or not you have the hypotenuse. But in this case, I don't have a hypotenuse. So, ka, toa. Notice that so, my sine function, or my sine ratio, has a hypotenuse in it. So that's out. Ka, cosine equals adjacent over hypotenuse. That also has a hypotenuse in it. That's out. Toa, however, tangent, is opposite over adjacent. So I can actually set this up and solve by taking the tangent of 32 and setting it equal to the ratio of opposite over adjacent. I know that if this is my theta, 11 is opposite of this angle and the adjacent is x. So I would set this up this way. Tangent of 32 equals 11 over x. I can multiply both sides by x. I get x times tangent over 32, or tangent of 32 equals 11, and then divide both sides by tangent of 32 to move it from the left side to the right side, so x is by itself, because remember, we always want to isolate our variable. So we get x equals 11 over tangent of 32. How in the world did they get this? So you have two options. One, scientific calculator. 11 over tangent of 32. If I have a scientific calculator, I'm literally going to do 11 over the tangent of 32 equals 17.6. That is exactly what they got. So that's option one. Now, if you are using a scientific calculator, especially if you are using one like this one off of Google, please make sure that you are not in radian mode, okay? You will use this when you take pre-calculus. You are currently in geometry and you're dealing with degrees because we're dealing with angles. Make sure that this button is pushed and that this is the one that is in black, not in gray, okay? Because notice I can change this from degrees to radians and back to degrees. If I did the same problem in radians, I would get a different answer. 11 divided by the tangent of 32. Earlier I got 17.6. You can see that right here. Guess what I get now? Not 17.6, I get a different number. Yeah, it's close, and it usually isn't gonna be this close. Okay, so I need to make sure that I'm in degrees so I get the right answer. Please make sure that you are doing that. The other way, if you don't have a calculator for some reason, or to double check, or whatever you're doing, you can always use a trig chart. Okay. What is the tangent of 32? Notice that if I'm using this, the first column is sine. Well, the first column is technically the angle. Second column is sine, third is cosine, and the last one is tangent. If I go to 32, the tangent of 32 is actually equal to 0.6249. So I can take that and divide 11 by 0.6249 and I'll still get 17.6. okay? Because I know what the tangent of 32 is. This trig table tells me. And notice from earlier, if you really want to know how to get the answers to these, okay, tangent of 0.2250, or sorry, the tangent of r equals 0.2250, so I can go back, see what's closest to 0.2250. My answer is going to be somewhere in between 14 and 15. 0.2, did I say 2250? Sorry, I was wrong. 2250 is somewhere between 12 and 13. Okay, 0.2250 is somewhere between 12 and 13. Here's 0.2126. 0.2250 would be somewhere in between, and then the next one is 0.2309. So there's no accurate way of getting the answer this way, but you can guesstimate that it's going to be between 12 and 13. So it's going to be 12 point something. Core concept, sine and cosine of complementary angles. This is basically saying that the sine of an acute angle is equal to the cosine of its complement. Remember earlier when I told you that the sine of r was equal to the cosine of s, and that the sine of s was equal to the cosine of r? We saw this same exact thing, or an example of the sine and cosine of complementary angles concept here. Sine of s gave us 63 over 65. The cosine of r gave us 63 over 65. These are complements of each other. Angle r and s, when added together, give us 90 degrees because every triangle is 180. And since this is already 90, then if I add angle s and r, it gives me 90 as well, okay? So, sine of s is technically equal to the cosine of r. The sine of r is equal to the cosine of s. That's exactly what this core concept is saying. If I get the sine of a, that's actually equal to the cosine of b. Or the cosine of a is equal to the sine of b, and vice versa. The sine of b is equal to the cosine of a, and the cosine of b is equal to the sine of a, just like we saw in that old example. Again, pause when you need to so that you can write these down. This is why it's on video. Now, let's see an example of this. Write sine of 56 in terms of cosine. So here what I'm thinking is if I have a triangle, one of them is 90 degrees, the other one's 56. If I'm getting the sine of 56, what is that equivalent to the cosine of? Well, what plus 56 gives me 90? Because remember, it has to be the complement of 56, which means it has to equal 90. So 56 plus what gives me 90? So subtract 90 by 56, you get 34. So the sine of 56 is actually equal to the cosine of 34. Because 90 minus 56 is 34. All right. Wow. Apparently that didn't come out well. This should say finding leg lengths. Find the values of x and y using sine and cosine. Round your answers to the nearest tenth. So, first thing I'm going to do is I'm going to identify that I have a angle of 26. So this is my theta. Here is the hypotenuse. And in this case, because both of these sides have missing lengths, I know that this is the hypotenuse because it's directly across from the 90-degree angle. And if theta is 26, x is my opposite, and y is my adjacent, okay? So, sine and cosine, so, they're both gonna need the hypotenuse. Sine is going to need, so the opposite over the hypotenuse, and the cosine of 26 is going to need ka, which is the adjacent over the hypotenuse. So let's do our sine first. So katoa. If I do that, the sine of 26 is equal to the opposite, which is x, over the hypotenuse. So if I have x over 14 equals the sine of 26, I'm going to multiply both sides by 14, and I'm going to solve for the sine of 26 when I multiply them together. So sine of 26 equals the opposite over hypotenuse. Sine of 26 equals x over 14. 14 times the sine of 26. If I need to know what the sine of 26 is, I'm in degrees. Sine 26 equals times 14 equals about 6.1. I can call it 6.14, whatever you want to round it to, unless it told us to round it to the nearest anything, which I don't believe it did. It actually did round to the nearest tenth, so 6.1, okay? So the value of x is about 6.1. Now, if I want to find y, I'm going to do cosine, adjacent over hypotenuse, y over 14 this time, okay? So if I solve that, cosine of 26 equals y over 14, multiply both sides by 14, cosine of 26 times 14. I'm going to do that here for you. Cosine of 26 equals times 14 equals 12.58. Rounded to the nearest tenth gives me 12.6. Boom, it is indeed 12.6. So let's talk about real life problems. No, not your problems. These math problems. So, solve real life problems. Notice that there's a man or a woman. I don't know who this person is. There's someone standing here, okay, with really cool looking arms. And this person has this little viewpoint, right? If they're looking straight, that's this dotted line. So from eye level, this dotted line represents your eye level. When this person looks up to this plane, an angle is created between the person's eye level and this new perspective looking up at the plane. Creates this angle that we call an angle of elevation, okay? It's created because the person's looking up, okay? So this angle is created because the person is looking up. The elevation's going up. Now, if this plane is flying straight, that is what this dotted line represents, okay? It's kind of like the plane's eye level. Now, if this plane decides to tilt and start flying downwards, it's going to create an angle of depression because it was originally going straight, and then it decided, you know what, it's time to land, so I have to start going downwards. It creates an angle of depression, okay, because it's caused by the eye level and now the plane going downwards, okay? It's caused by the plane's depression. It's going down. So the angle that an upward line of sight makes with a horizontal line is called the angle of elevation. This is an upward level of sight. And then the angle that a downward line of sight makes with a horizontal line is called the angle of depression. This is the downward line of sight. Please make sure you write these down, as we will be doing problems with these. And remember, you can always pause the video. Modeling with mathematics, part A. You are measuring the height of a spruce tree, whatever that means. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height h of the tree to the nearest foot. So there's a lot going on here. There is a picture that we can look at for reference. So again, it's saying that you're standing 45 feet away. The angle of elevation is 59 degrees. We need to find the height of the tree. So we know we're 45 feet away. Here's my angle theta. Figure out the height of the tree. Well, if I'm looking at this, based off of all of this, even if I didn't have the diagram, I know I can make this. Here's a tree. I'm 45 feet away. Angle of elevation means we're looking up. So this has to be 59. Figure out how tall the tree is. Awesome. Well, if 59 degrees is my theta, my angle of elevation, here's my hypotenuse, which means the height is my opposite side, and 45 feet is my adjacent. If I'm solving for the opposite and I have the adjacent, what trig function can I use to solve for the height of the tree? That's right, I can use tangent. So the tan of 59 is equal to TOA, opposite over adjacent, h over 45. And I can solve that. Tangent of 59 equals opposite over adjacent, or h over 59. Multiply both sides by 45. 45 times the tangent of 59. So the tangent of 59 times 45 equals about 75 feet, okay? Or 74.8 or 74.9 feet, okay? I would round it to the nearest tenth. I see that they rounded it to 75. That's fine. 74.9 would be the best answer. If you put 75, that's okay too for this specific problem, but I would leave it this way more often than not. Oh, never mind. It said find the height to the nearest foot. So 75 feet. Here's part B. You are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance, x, you would ski down the mountain to the nearest foot. See, now I'm paying attention to the fact that this says round to the nearest foot, because I didn't earlier. So, in this diagram, here's the skier. From the front of the ski, they're going to draw kind of a eyesight or line of sight going straight across horizontally through the horizon. This is the horizon line. And then they're going to draw an angle going downwards from the horizon line, which is going to be 21 degrees. And they're telling you that the altitude that you're at is 1,200 feet, which means that that's your height, your vertical height. The angle of depression is 21 degrees, and it wants you to find the distance that you're going to ski down the mountain to the nearest foot. So the distance is going to be from the front of your ski all the way down to the bottom of the mountain. That's what we're looking for. Now, if I draw this out, I could have drawn a line going across as my horizon line. I would have drawn the elevation as a vertical line, so I would have known automatically that this vertical and horizontal made a 90-degree angle, which means that this distance that I'm looking for of x has to be my hypotenuse, because it's directly across from the 90-degree angle. And if 21 is my theta, 1,200 is my opposite, which means this horizon line is my adjacent. So right now I've got my opposite and my hypotenuse. So if I want to find a trig function of 21 and use my opposite and my hypotenuse, which one would I use? So, ka, toa. Which one has opposite hypotenuse? Good, it's so, right? It's the sine function. So I would find the sine of 21 equals 1200 over x. And I would solve that. The sine of 21 equals opposite over hypotenuse, or 1200 over x. Multiply both sides by x. Then divide both sides by sine of 21 to get x by itself. 1200 over sine of 21 gives you about 3,348.5, which is 3,349 feet. Okay, and I could have done that on the calculator. 1200 divided by the sine of 21 equals same exact number they got, 3,348.5, which rounds up because it ends in 0.5 to 3,349. And that's it. So again, if you need to go back and rewatch something, please do. Remember, you can pause, you can rewind, you can replay. If you forget something by the time you get home, you can rewatch it, fast forward through the stuff that you already know. No worries, here's your classwork/homework. I know you have time after this. This video is not 90 minutes long, okay? So please work on this. And that's it. All right, thanks. Enjoy.